Hello everybody, this is Nino, and today I'm going to show you my theory of logical triangulation. It is a new kind of logic which is focused on reasoning about the consistency of patterns rather than reasoning on cause and effect, as is the case with classical logic. The problem of classical logic is it generally works by deducing from causes some certain effects by use of some rules. Obviously, in order to make such a deduction of effects, you will need to determine the causes and the rules. And what is quite interesting, particularly when you are designing an artificial intelligence system, is that the rules are something that you can kind of quickly make your mind up about, but it is somewhat hard to find the causes. In particular, it turns out to be hard to foresee all possible effects when choosing a set of causes. Many projects which are reasoning by symbolic logic based on causes and effects are failing because of seeking the causes. And now I was asking myself, how can we avoid that? In particular, looking at the fact that we humans are in fact participating in the world by looking at patterns, I was asking myself, how can we handle patterns? So the solution was obviously some sort of pattern logic. And the main idea of logical triangulation is that you are looking at patterns and you are saying something about their consistency. You say whether a pattern is more plausible than some alternative pattern, thereby allowing you to choose some patterns over other patterns in the reasoning of, say, an artificially intelligent agent. The question, therefore, is about the strengthening, or alternatively, the weakening of pattern relations. And this is done by evaluating the potential of coexistence of certain pattern relations. So the things to determine are which patterns are consistent. The advantage is this system works on any patterns, and you no longer search for causes, as it's not about clauses with heads or tails, it's about pattern consistency. The disadvantage which I have discovered in my practical implementations is that really reasoning down to the core of patterns, really looking at every relation, turns out to be quite slow in practice. But nonetheless, it is an interesting theory, and I believe that no matter what shortcuts might be necessary for you in practice, it is worth having a look at it. Now, you can actually calculate according to my proposal. You can calculate by using this logic and with patterns. However, it is not the same calculation as in predicate calculus. You do it in a different way than with cause and effect clauses. In the following, we shall derive the manner of exact calculation by means of logical triangulation. And our aim shall be to find a way how to determine the consistency of some given set of patterns. And as I said, that will give you the good patterns and the bad patterns, and you can thereby decide in your artificial intelligence designs which patterns shall prevail over which other patterns. Starting with the most simple possible environment, imagine an abstract space of thoughts, let's say concerning symbolic reasoning, and there could be terms. Initially, let us say that that space is empty. Well, that's a simple case. You cannot reason about anything whatsoever. To make things a little more interesting, let us now place a term, the term A, into this thought space. This term shall henceforth be referred to as an atom, to make clear that it is an axiom, it is inseparable. We don't care what it consists out of. We say it is a symbol, and it exists because it exists. There is really nothing further you can do about it. Once something is put into the thought space, it is there. You're not going to question it further down. And deciding which terms to put into, let's say, the thought space of some given system is going to be a design decision. What happens if we add a second atom, so we have two atoms? What can be said about them? Well, you can say that they must be somewhat different, or otherwise they would not be two distinct atoms, they would be one and the same. If they would be too similar, you cannot take them apart. I mean, anybody of you who knows twins knows the problems associated with that. Now, they cannot be, however, totally different either, or they would not be thinkable together. As a matter of fact, I can propose you a little thought game. It will turn out impossible for you to imagine two terms which have absolutely nothing in common. Even when you say that you're comparing apples and oranges, it turns out that you're comparing fruits. If you are looking at a rocket and a grasshopper, then maybe it inspires you that both of them are covering large distances quickly. You cannot think of things that have nothing to do with each other at all, or it couldn't be thought in one and the same mind. Therefore, you can say any two terms in the thought space are somewhat different and somewhat similar. This already defines the two basic relations on which my theory is based. They are namely the analogy connection and the vicinity connection. I'm abbreviating them as calling it an ana connection and a vic connection. In an ana connection, each term can replace the other. Mind you, this is an abstract notion of replaceability. The vic connection says if each term rather does not replace the other, then these two terms rather appear jointly. If they would not appear jointly, then they would replace each other. Hence, I am saying that I am considering in my theory those two relations opposite to each other. You can then start to consider which connection shall prevail. You cannot yet do this based just on two terms, but that is going to be the basic question in this theory. Given two terms, which connection prevails? While looking at it, there is no head or body of a clause. You will only be looking at potential coexisting patterns. Let's first examine the ana connection. I said it's a notion of abstract replaceability. So you will be mostly looking either at one atom or at the other atom, but not at both at once. For instance, you may order coffee or tea. It might feel cold or hot. And when you do something, you might receive a reward or a punishment, but not both. Of course, I tell you, once again, we're talking of a prevalent and usual connection. Of course, you can go to your local coffee shop and disprove me this very moment by ordering a coffee with a tea. It will be kind of strange, you can do that, but you won't change the general prevalence of the relation. At least, not by much. Now, looking at the Vic connection, you can also say the same thing as before. Two atoms rather appear together. Like for instance, you may have coffee with sugar, tea with sugar, or, and that's quite interesting, tea with milk. Of course, tea and milk could also have more of an ana connection, that you order either tea or milk. So it's not an absolute thing, but in general, you wouldn't regard these terms as replacing each other. For instance, if you go to your local coffee shop, it is unlikely that you either buy a cup of coffee or that you order a cup of sugar. Of course, you can disprove me by going there and offering them to give you a cup of sugar straight away, but that's not what usually happens. So we can generally say these terms prevail having a weak connection. As I said, any two atoms can have both connections. The question is which one usually prevails. And for simplicity, in my system designs I do this as well, you can focus on the winner. But don't forget that even if one connection prevails, that is not necessarily an absolute status, and certainly nothing immutable for any time ever after. It only depends on what you are observing from the patterns which are placed into the thought space. So, you have the basic situations of either the weak connection prevails between the atoms A and B, or the ana connection prevails between these said atoms. Now, let's make it more interesting. What happens when a third atom is introduced into the thought space? And just to make it clear, of course you can introduce many further terms, but they can be each time looked at in groups of 3. Well, when you have 3 atoms, then you're having 4 possible triangles of relations between these atoms. And I'm saying 2 of those relations are consistent and 2 of those relations are inconsistent. Looking only at the 3 terms, you cannot say which side is particularly consistent or particularly inconsistent. You can only say that these 3 relations look pretty likely or that they look unlikely, and then you can strengthen them all or weaken them all. But you are treating each of those correlations as a whole. You are not just looking at one side. We shall now explore the possible logical triangles. I will show you in what way they can be said to be consistent and inconsistent based on examples. But do keep in mind that the question is abstract. We are talking here of A, B, and C in reality. Now, as I said, I'm giving you atoms here with terms for illustration purposes, but don't get carried away with that. This is just to make it easier to grasp, as it is the first time you are likely to hear that. So, you can have tea with sugar, or coffee with sugar. And it's also quite likely that you can have tea or coffee. So you're saying that these 3 relations, namely 2 weak connections and 1 ana connection, are consistent, and you can strengthen each relation. That means when you're looking at patterns, you can say then, hey, after this comparison, I can really say that this is a pretty strong weak connection, that's a pretty strong weak connection, and that is a strong ana connection, and I am more certain of these relations than I was before doing this triangulation, this comparison of the sides with each other. Now, inconsistent is if you say, yeah, tea you can have with sugar, coffee you can have with sugar, and tea you can have with coffee. You can say, no, actually, you know what, that is nonsense. This is an abstract inconsistency. And if one side were changed into an ana connection, for instance, tea or coffee, each of them with sugar, you would again have a positive triangle. But it isn't, and as it stands here, you can only say something is wrong, but you can't actually say which one is wrong. You can only say, I'm a bit uncertain of this relation of 3 atoms, and you weaken each relation. Now, I understand your temptation to say, but it's obviously wrong that you can have tea with coffee. You deduce that, however, only based on your general life experience. In other words, you are looking at more information than is available to you in this particular logical triangle, which is obviously not allowed. The truth is, looking at it from an abstract perspective, you can only say 3 weak connections are impossible, and you weaken each single one of them. You say, I'm now not so sure whether I can have tea with sugar, not so sure whether I can have coffee with sugar, and I'm not so sure whether I can have tea with coffee. Now, if these 2 relations are going to be strengthened and repaired, so to say, by further triangles, that's entirely possible, but you can't deduce it from this triangle. Consistent is, of course, a mutual relation of analogy between all of your atoms. You can have tea or cacao, cacao or coffee, and coffee or tea. You can say that makes you actually pretty sure that these connections are correct, and you can therefore strengthen each single one of them. And inconsistent is, of course, if you're having 2 ana connections and 1 weak connection, like tea or coffee or cacao, but tea with coffee. You'll have to weaken each relation. And once again, you can't simply go ahead and say, I know which is the wrong relation, it is tea with coffee. You know that only by looking at information outside of the triangle, which you are not allowed to. You can only say, this sort of relation is unacceptable. So, we looked at each of these possible triangles, and I hope I made clear that you can only judge the consistency or inconsistency of each one of these patterns as a whole. You don't have cause and effect, you don't have head or body. And that is actually the main difference to classical predicate calculus. Now, this is not to say that you cannot express logical triangles by classical logical calculus. You could say that, for instance, this triangle is expressible by saying A and C and B and C, or A or B. But you can't say that one of these relations is governing the other relations. You can only say that this setup is true, and that's all you can say about this setup. I know that you might pay attention to this interesting fact here that I have grouped this. You can say that this whole equation is equal to true, that I have grouped it into 2 parts. It will become clear in a moment, because in fact you can deduce each relation from the other 2. Let's leave this be for a second. But generally speaking, I'm saying you can express that by classical logic if you wanted to, but it is clumsy compared to expressing it by logical triangles. And of course, if you wanted to, you can implement them in a gradual way, so that you say that A and C is somehow a pretty strong connection. As I mentioned, you can compute one unknown side, and you can compute it in that way that you take 2 known sides and try to make it a positive triangle. Why? Because you want obviously to create something consistent. So for instance, to show a few examples, if you know that you can have tea with sugar and coffee with sugar, then you can conclude from that you can have either tea or coffee, but not both. So two Vik connections can be used to determine one ana connection. And you can say that this ana connection really determines also those other two, and they determine it. It is a form of coexistence. Again, if you're having here tea with sugar, and let us say that this time you know that you can have either tea or coffee, you can say that Vik and ana lead to Vik, that you can therefore have coffee with sugar. Again, this is a consistent triangle. And you can have this final possibility of a consistent triangle if you have tea or cacao, or tea or coffee. You can from there conclude that you can have cacao or coffee. So ana and ana lead to ana. Please realize these terms which I have used here are only examples to make it more intuitively clear to you. But in fact, it is a sort of abstract calculations and the calculation mode of my theory. You say Vik and Vik lead to ana, Vik and ana lead to Vik, and ana lead to ana. From this, you can have chain reactions and the creeping forward of conclusions, and it can become rather involved with the time. Let's say, for instance, that you know only this empty shell of relations. Then a cascade of conclusions can work its way forward by saying, obviously, those three atoms should now create a Vik connection. From this, an ana connection can be deduced. Again, a further ana connection can be deduced from the other two ana connections. Now, from the concluded ana connection, another Vik connection can be concluded, and finally you can reach one further Vik connection. You can create also all sorts of other conclusions here in between these. What I'm basically saying is, thereby your system, operating by means of logical triangulation, can discover a lot more relations between terms than are given to it a priori. Now you can obviously say, hey, but what happens if you take other terms? What happens if you are evaluating one relation not only according to those two, but to more? Can you do that? The answer is yes. One and the same relation between terms can participate in a multitude of logical triangles, and some of those might be consistent and others might be inconsistent, and that may then finally determine this connection in a more gradual way. And actually, this determination of the connection by interaction of several logical triangles can even change the nature of this connection. It can flip it, and it can make another type of connection prevailing. Let us say, for instance, you are looking at this group of relations. Then you have here two inconsistent triangles, the central one and this left upper one. And you can say that all of those other relations, by strengthening and weakening the consistent and inconsistent triangles, may have the effect of even flipping the relation and saying, you know what, these two atoms are not rather having a Vik relation. From the entire logical construct, it appears much more likely that they are having an ana relation. And thereby, I believe, you realize already, quite complex reasoning can be undertaken. Any relation can participate in a multitude of other relations. It can be determined from them then whether it's a good idea or rather should be flipped into its opposite. If relations are unknown, they can be concluded. And generally speaking, you're able to do rather complex calculations on the likely nature of patterns by looking at their relations to other patterns. This is actually the core idea of reasoning by means of logical triangles, and I admit that my implementations have so far been even rather simple. It is of course open to you to do anything you wish in a more complex manner. Now let's look at an entirely different point. What is a relation? So far we were talking about the relations between atoms. But what is the relation itself? Well, as we said that in the thought space there can be terms which we call atoms, then what other thing could a relation be if not an atom itself? And you can say that the relation, for instance, the big connection between A and B can be said to constitute the atom X, and the ana relation can be the atom Y. Indeed, by expressing relations by means of atoms, you can construct very complex hierarchies and relations between patterns. So, how come actually atoms to exist within the thought space in the first place? We can now say in three possible ways. Either they are somehow placed there a priori by instincts, or you can say that they have been somehow perceived by means of sensors. These I call the elementary atoms. Or they signify relations between atoms, and these I call the derived atoms. And in fact, by looking at this, you can express any possible perception and action scheme. And the derived atoms, like this X and Y, which I was just showing you here, X and Y, these derived atoms can participate themselves now in logical triangulations, just like any and all other atoms. There's really no difference. I'll give you an example. Any atom can relate to any other atom, whether it is derived or elementary. And you're having here, for instance, a logical triangle of A, B, and C. However, at the same time, the atom X signifies the relation between A and B. And the atom X can itself be related to further atoms like R, S, Q, and it can itself cause logical triangulations by its correlations to other atoms. So you can have rather complex constructs by looking at the relations themselves as atoms. And indeed, complex atom hierarchies can arise this way, and triangulation is possible at any level. You can say, for instance, that you're having here the elementary atoms A, B, C, D, E, F, G, H, I, and J, and that you're then hierarchizing them, here for instance A and B into K, or M consisting out of the elementary atom F and derived atoms K and L. So, you can have here any relation of patterns you like, and patterns can mutually evaluate each other by means of logical triangulation at any level. What I am trying to point out to you is that triangulation is not somehow confined to derivative or elementary atoms. It's not something where you say what level of reasoning are you at. Any atom can correlate with any other atom, and therefore you can have any sort of expression you like. The system is free in its reasoning absolutely. Now, you can also say that a system can be smarter or dumber, such as artificial intelligence for instance, depending on how many triangulations it can perform to maintain consistency. Because there are a great number of triangulations possible, you can say that it performs only some of the possible triangulations, with only some of the atoms which it deems currently important. Therefore, it can mostly not guarantee you absolute consistency between the perceived patterns, but it might be able to tell you a sort of local consistency of patterns, that you say those patterns that you currently pay attention to should be structured in some particular way by Vic and Anna connections. And so you can have also more and less capable systems. Kindly note that all what I'm telling you so far is purely abstract. It is independent of the type of information, and it is not of importance whether we are talking about text, video, audio data, tactile, and whatever else you want. We care here in this theory, and actually in each and every of my system designs, about perception of patterns. We do not deal with physics. I believe therein lies a mistake often done in the design of artificially intelligent systems, that people somehow try to reflect the physical world. You can never do that. If I show you an apple, you don't even know whether there is a wormhole on the other side or not. You only see what your sensors give to you, nothing more. Now, it's all kind of lovely that we can reason about the coexistence of patterns, but that's not all what can be done. You can actually use patterns for planning. You can namely say that what you call the present, that is the present hierarchy, should have some strong connection to something, to some future, and that is another pattern hierarchy, and you can call that the plan. In fact, if you're having an artificially intelligent agent which reasons on patterns, if you give this agent some sort of construct and let it find out what happens next, then this agent, by looking at the connection of the present to something else, might tell you what the future is going to be like. So in fact, you can use logical triangulations and the relations between atoms in order to find the consequences to the present and to evaluate those consequences according to the patterns of your experience. So you make an intelligent plan consistent with the present knowledge possible. It's just very natural in such a sort of system. But is this a good plan? Now, as I mentioned, it is maybe hard to judge the consistency of a plan based on absolutely all knowledge. Therefore, in a system design, you might resort to a kind of locality of truth maintenance. You can say that according to the patterns currently observed, this looks plausible, and a smarter system is going to look at more things, thereby performing more logical triangulations in order to determine the plausibility of some plan, of the continuation of the present into the future. Now, let's go to the fancy stuff, and this is going to go now towards the end of this video. What other things can you express, and how can they be part of the logical triangulation? I'm saying, actually, you can have instincts. For instance, an instinct is a connection between two atoms, and you can say that A and B have a big connection. It is preset, it's not perceived, it's not evaluated, it is said to be that way. And now, if A and B correlate with some further atom C, then this instinct may participate in the logical triangulation. It may strengthen other relations which are not instincts. It may also weaken them. It itself is immutable. It is just preset. It's going to be this type of relation of that strength, and there's nothing you can do about it. But by interacting, and you remember the chain reactions, this can go pretty far, By interacting with other relations, you can have a sort of influence of preset things to the general thinking mechanism of the system. Given the locality of the thinking mechanism, so looking at locally important relations, sometimes certain instincts could prevail over others because the system simply does not evaluate an instinct given a set of relations because it doesn't deem it important. So you can actually have an agent have a rather free and independent sort of behavior, still somehow governed by instincts when things start to go into their area of reasoning. This maybe was a bit too abstract, but we can say, for instance, you run away from spiders. Yeah, but you run away from spiders because you're afraid of spiders, have some instinct, only when the question is about spiders. You know, like when you are just licking an ice cream in the hot summer rays of the sun, you're not going to think about the spiders. And if you have a craving for, let's say, honey, then that might hit you more when you are thinking about food and not when you are checking in at some airport. So that's actually the matter with the locality of reasoning. Certain things are important in certain situations. What else can you have? Well, I dare say that by means of logical triangulation and instincts, you can even have something like moods and even morals and, yeah, so to say, feelings of a system. It will behave as having them. For instance, if you have here luck, smile, ice cream, sunshine, and happiness, then, and love, you can have some sort of quite powerful local consistency maintenance based on those terms and their relations. If some other relation pops up anywhere here, then you will have here a network of patterns which is going to be very influential on any new connection appearing, thereby steering the general behavior of an artificially intelligent agent based on logical triangulation. It will behave generally rather in a certain way because you already have a powerful network influencing it. I even go so far as to say that using logical triangulation you can create something like dreams. Alright, this is more of a personal speculation, but I am saying that you can say chaotic triangulation might be an expression of dreams, where you're saying you don't try to follow a goal, you're simply looking at patterns generally chaotically correlating to other patterns. You are then performing perhaps some sort of truth maintenance across the possible knowledge of such an artificially intelligent agent. That you're saying its task is not to interact with you, its task is to get its mind in order, to free its pattern relations from contradictions by correlating patterns and evaluating them, and even correlating and evaluating them in unusual ways, in ways you would not normally think of. So you can say that it is a sort of background thinking, aiming to generate more consistency in the system, and that it is not actually going to some certain conclusion. Well, that's about it. That is my theory of logical triangulation, and I thank you very much for listening. I will show you 3 example implementations of systems regarding this theory. They will be based on something which I'm calling directed triangulation, namely, when you're having here some relation between atoms, I'm currently showing them neutral, but it is possible to have them going in some certain way. Anyway, you can find the full theory on my website, and I hope that those example implementations can show you a little bit better how reasoning with logical triangles is possible, and that it is a powerful tool that might be quite useful for you and your own experiments. Thank you once again for watching. I hope you will check out my further videos as well, and I wish you much success in your artificial intelligence experiments. Goodbye.